Welcome to The Explainer. We're here to break down the big ideas from really important sources. And today, oh man, we are diving into John Gilbert's Software Architecture Patterns for Serverless Systems. This book is basically the blueprint for how all the modern apps you use are actually built. So you ever wonder about that? How your favorite apps seem to get new features all the time with no downtime and they just work? Well, it's not magic. It's because of a huge shift in how we think about building software. And to really get our heads around it, we're going to use a really simple analogy. That's it. A food court. I mean, think about it. Imagine one massive kitchen trying to make tacos and pizza and sushi all at the same time. It would be an absolute nightmare, right? But a food court, well, that's organized. It's specialized. It's super efficient. And that food court model is going to be our key to unlocking everything. So let's start with the very first step, tearing down that one giant kitchen. All right, section 1. We've got to talk about breaking up that one giant chaotic kitchen, what people in the biz call the monolith. It's the old way of doing things, and honestly, it was holding everybody back. So the new way is all about these things called microservices. In our food court, this is like having a totally separate stall for each type of food. You've got one stall that just takes orders, another one just handles payments. Each one is small, it's focused, and it does its one job really, really well. Now, here's where it gets really cool. Each team gets to own their entire stall. So, if you're on Team 1, you own the ordering system. That means all the code, probably in a repository named something like ordering service, is yours. You control the whole shebang, from the database all the way to the logic. And that autonomy is huge, because it means you can make changes and push updates without needing a meeting with every single other team. But wait a minute, what does the customer see? They don't see a dozen different little stalls, right? They see one unified app. Well, this is done with something called Micro Frontends. Each stall has its own storefront, its own little user interface, that ordering app, for instance, and they're all cleverly stitched together so it looks and feels like one seamless website. Okay, so if all these stalls are independent, how in the world do they coordinate to get an order out the door? They can't just be shouting at each other across the food court. That would be total chaos. No, they use something way more elegant. It's called an event-driven model. And you can just think of it like a public address system for the whole food court. When something important happens, an announcement is made. The ordering stall doesn't boss the payment stall around. It just gets on the PA and says, "Hey everyone, a new order has just been placed." And this is exactly how that chain reaction works. An event is just a fact, something that happened. So first, that placed order event gets broadcast. The payment stall, which is always listening for that specific announcement, hears it and springs into action. Once it's done, it broadcasts its own event, payment authorized. Then the delivery stall hears that one and assigns a driver. You see? Each service just reacts to the news it cares about. It's beautiful. Now, in the technical lingo, each of those announcements is called a domain event. It's an unchangeable fact. It happened, can't be altered. And this becomes the official record, the absolute source of truth for the entire system. And the services that are built to listen for these events, you'll often find their code in repositories that end with process. This all leads to a really important question, though. How do we decide what goes into each stall? I mean, how do you draw the lines between them so that they actually make sense as independent services? The secret here comes from a practice called domain-driven design, or DDD, and Gilbert's advice is just brilliant. He says, stop focusing so much on the things in your business, like a customer or an order. Instead, focus on the actions, the verbs. What does the system actually do? So DDD gives us this tool called a bounded context. The best way to think about this is like the official business plan for a single stall. It defines exactly what that stall is responsible for. For the payment stall, a customer is basically just a credit card number. But for the delivery stall, a customer is a physical address. Each context defines its own language, and that clarity prevents a ton of confusion down the line. Okay, so we've got our independent stalls and they're communicating through events. But what happens when the lunch rush hits? What happens when the food court gets incredibly busy? We need a smart way to handle all that information without creating massive traffic jams. Well, the old model is like having just one counter where people are trying to look at the menu at the exact same time other people are trying to place orders. It's a total bottleneck. So there's this pattern called CQRS. That stands for Command, Query, Responsibility Segregation. And it solves this by creating separate lines. One line is just for writing new data, placing an order. and a completely different line is for reading data, like browsing the menu. And this visualizes it perfectly. On the one hand, you've got that single congested path. But then look at the other side, CQRS splits them up. This is a game changer. It means a huge rush of new orders coming in on that command path won't slow down the experience one bit for thousands of other users who are just looking at the menu on the query path. It makes the system way more resilient. So let's bring it all home. The really crucial point here is how all these patterns, the microservices, the events, the domain-driven design, and CQRS, how they all come together to create a system that isn't just fast. It's a system that is literally built for constant, rapid change. This diagram from the book gives us that perfect bird's eye view. At the smallest nano level, you've just got a single, tiny serverless function. You bundle those together to create a microarchitecture. That's our food stall, a complete service. And then you compose all those services together into the macro architecture. And that's the entire food court, our complete application. And this right here, this is the ultimate cheat sheet. What you gotta take away from this is that it's not just theory. These patterns create a super clean, predictable structure that developers actually use every single day. You see a repository ending in app, you know that's a user-facing storefront. You see one ending in process, you know it's listening for those PA announcements. This organization is what makes the whole thing work. So why does all this matter? It matters because when you build just systems this way, the team running the taco stall can completely redesign their kitchen and it won't affect the pizza stall one bit. This is what allows businesses to move so fast, to innovate and deliver new features to you, the customer, constantly and safely. And all of that architectural freedom really just leaves us with one final and kind of provocative thought. When your ability to change and adapt is no longer held back by your technology, the only limit left is your imagination. So, what will you build next?